Let's jump right in. A block has a mass of 4.55 kilograms and a volume of 0.002 cubic meters. You calculate the density, but you round it early to 5 kilograms. Okay, which mark scheme trap did you just fall into? Is it A, wrong variables, B, early rounding, or C, missing units? Lock in your answer in your head right now. Choosing the wrong option here is the exact trap that causes so many students to just bleed method marks in the Cambridge IGCSE 0625 physics exam. We're skipping the fluff today. We are jumping straight into a high-stakes exam trap that literally ruins grade boundaries. So what did you pick? If you chose B, early rounding, you hit the nail on the head. You are absolutely correct. But here's the thing. Simply knowing the answer to this one specific question, well, it isn't enough. You really need to understand why the examiner penalizes this so heavily in topics like mass, weight, density, pressure, and resultant force. In this explainer, we're going to look at what's actually going on behind the scenes of the mark scheme, and more importantly, how you can avoid these fatal errors on exam day.
Now, ordinary rote revision totally fails here, because memorizing formulas just isn't enough. You have to avoid these highly specific mechanical errors that examiners are constantly on the lookout for. Let's look at the direct link between a seemingly simple mistake and its massive consequence. Missing your units? That's a total loss of your final mark. Just gone. Rounding too early? Well, that gives you an inaccurate final value, which is then going to cascade through a multi-part question and absolutely destroy your score. What about vague explanations? That means you miss the command word fulfillment entirely. And graph axis errors mean you lose vital data analysis marks. You see how the stakes escalate so quickly if you aren't paying close attention to the mechanics of your answer?
So how do we fix this right now? Well, here is your first quick win. Always, and I mean always, substitute your raw values along with their units directly into the equation before you do any calculating. If you want an immediate, foolproof way to secure your method marks for pressure or resultant force, write down your substituted values with their units before you even touch your calculator. Seriously. It forces your brain to double-check that you're working in standard units, like using kilograms instead of grams, before the math even happens. It is a tiny, tiny habit, but it saves massive points.
Now, you might be wondering how to structure these calculations perfectly every single time to guarantee those marks, right? Especially when the questions get super tricky. Well, stick with me here, because in just a moment, I am going to show you the exact examiner wording clue that flips the mark scheme completely on its head. But first, you need the framework that makes that clue super obvious, because without this framework, you're essentially just playing a guessing game with what the examiner wants to see on your paper. Section 1. The Data Detective Framework. Okay, to conquer mass, weight, density, pressure, and resultant force questions, you need to stop acting like a passive student who just memorizes things, and start acting like a data detective. It's a massive shift in mindset. You're not just recalling facts from a textbook, you are investigating the specific data provided in the exam question, and you're building an airtight, logical case for your final answer. This four-step framework is your ultimate blueprint for every single calculation and explanation question. Step 1. You state the core concept. Step 2. You extract the exact evidence or data from the source page. Step 3. Apply your scientific reasoning. And Step 4. Lock it all in with examiner-safe wording. Applying this systematically is the absolute best way to safeguard your grade boundary. So, let's break down how to actually execute each step.
Before we apply the full framework to a complex problem, you really have to anchor your answer with precise, Cambridge-approved terminology. This addresses Step 1, the concept. Let's take this definition for resultant force as an example. Listen to this phrasing and lock it in. It is defined precisely as the single force that has the same effect as all the forces acting on an object combined. Memorizing this exact phrasing is completely non-negotiable. If you use vague words, like saying the overall push, the examiner literally stops reading and you drop the mark immediately. No way around it.
All right, let's put on our detective hats for a second and look at a flawed student approach to a forces question. I want you to try and spot the specific error here that completely misaligns with the provided data. Look closely at their process. Can you spot where the physics just falls apart? First, in Step 1, they calculate mass instead of weight. Then, in Step 2, they completely leave out the gravitational field strength, lowercase g. And in Step 3, they write a conclusion that is not even supported by the data table. This is a classic, panic-induced sequence of errors that happens under exam pressure. They missed the core concept, they ignored the correct evidence, and their reasoning just completely fell apart. Let's look at this side by side to really understand what the examiner is seeing. Notice how the flawed answer on the left says, the object falls because it is heavy. 50 divided by 10 equals 5. Right off the bat, it uses vague explanations, it completely misses the units, and fundamentally confuses mass and weight.
Now look at the improved top-band answer on the right. This perfectly applies our data detective framework. It states the concept, resultant force is downwards. It provides the formula evidence, W equals mg. It shows the scientific reasoning with substituted values in units. W equals 5.0 kilograms times 9.8 newtons per kilogram. And finally, it concludes with exam-safe wording and correct units, equals 49 N. Do you see the difference there? One is a panicked guess, the other is undeniable proof.
Utilizing this data detective framework ensures you hit exactly 100% of the method marks and the command word fulfillment required by the examiner. When you clearly lay out the concept, the data, the scientific reasoning, and the safe wording, you literally leave zero room for the examiner to deduct points. It makes your exam paper absolutely bulletproof. You aren't just handing them an answer, you are practically forcing them to award you the maximum marks.
So, we solved the early rounding trap from our initial poll, and you now have the ultimate framework to secure all your calculation marks. But this actually creates a massive unresolved problem. What if the very next question on the exam asks you to design the practical investigation to test this resultant force data, complete with graph scales and uncertainty? If you don't know how to handle those linked practical data analysis skills, you are going to lose the entire second half of the question's marks. All that amazing calculation work you just did will be for absolutely nothing if your experimental design falls flat.
To get that final clue and absolutely master table design, anomalies, and practical improvements for the 0625 syllabus, you have to watch our follow-up explainer right now. The exact step-by-step method to secure those practical marks is waiting for you in the next session. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click the next explainer on your screen right now to bridge that gap. After all, if you can calculate the resultant force perfectly, are you really willing to let those practical marks slip through your fingers? I'll see you over there.